Okay, we have a right triangle, as you can see from the corner. It's 90 degrees and the hypotenuse is 7, and we're trying to find the length of one of the legs. So we simply use the Pythagorean theorem, which simply states the sum a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. And we just fill in the numbers. So we have x squared for a plus 3 squared for b equals 7 squared. So our answer is x squared equals 49 minus 9, in which case x squared equals 40, and x equals the square root of 40, which equals 2 rad 10. And of course, there's no plus or minus in this case because distance or length has to be a positive number. Okay, this is a basic distance formula question. We have 2 points, A and B, and in this case we're given point A and we are given the distance to point B, and we're just going to basically solve this and see what we come up with. There's actually going to be a little bit of a surprising solution. So let's first start with a good way to approach a problem like this is simply to put down a formula that will work, and in this case let's use the distance formula. So the distance d equals the square root of x of 1 minus x of 2 squared, the distance between the x's, plus y sub 1 minus y sub 2, which is the distance between the y's, squared. And now let's just plug in the information that we're given. The distance is 15, so 15 equals the square root. And x of 1 is what we're going to look for, and x of 2 is 3, what we're given, and y sub 1 is what we're looking for b, and y sub 2 is what we're given, and we have our basic question filled in. And now to get rid of this radical sign, let's square both sides, and so we're going to get 225, that's 15 squared, is equal to x of 1 minus 3 squared plus y sub 1 minus 7 squared. And that is actually the solution. And for most of you, it's probably familiar because that looks like and is a circle where the center is 3, 7, which is our point A, and all points x of 1, y sub 1 would satisfy the radius, which is the square root of this, which is 15. So actually there's an infinite number of solutions, and to confirm our answer, let's draw a quick sketch as best as we can. Okay, so we'll draw our x and y coordinates. Okay, and 3, 7 is our center, so 3, 7, let's put it about right here. This is 3, 7. And the radius is, as we mentioned, 15, which is the distance from A to B. This is point A, and B is going to be anywhere 15 units. So 15 units might be here. It could also be down here. These are both 15 units, which are also the radii over here. And for example, 15 units horizontally would be negative 12, 7. And 15 units this way would be 18, 7. So those are 2 possible answers. And 15 units straight down would be 3 minus 8, and we can make our little circle, and it's going to go like that. And you can see these are all 15 units from the point 3, 7. And we can even check our answer. Let's plug in 3, negative 8. So we would have 3 minus 3 is 0. Negative 8 minus 7 is negative 15, and 15 squared is 225. And actually you could plug any of these points in and they'll all come out to 225. Okay, a racer runs 4 miles due north, then turns and goes 5 miles due west, and then turns once more and goes 6 miles due south. How far is the runner from the starting point? So this is a word problem that's going to use right angles because we're turning north west, south, those are in straight directions on the compass. And we will get to use the Pythagorean theorem. So the first thing I like to do with any word problem is to draw a picture, and helps, and maybe even put a formula down. So let's draw a quick sketch. So we have our runner right here, this guy, and he's going to start here at the starting point and is going to go due north 4 miles. So there's a 4, and then turns west, makes a left, and goes west 5 miles, and I'll try to draw it as best I can to scale. I don't have graph paper here, I'm just drawing a sketch. And then finally makes another left turn and heads due south for 6 miles. How far is the distance back to the starting point? And again, we just simply have to use the best knowledge that we can to find what the distance is from this point to here. We'll call this D. So you can almost see that we sort of have ourselves a right triangle here. All we have to do is fill in this one space right here, like so, and we have ourselves a right triangle upside down. And then a question now is, what is the distance from here to here? Well, the distance from here to here is the same as that, because these are parallel lines. These are also right angles. Therefore, this is 5. And then finally, what's the distance from here to here? Well, we know that from here to here is 4. Here to here is 4. Therefore, this must be 2. So we have ourselves a right triangle of 2 and 5 are the legs. And then the distance is the hypotenuse. And we will simply use the Pythagorean theorem, which is a squared plus b squared equals c squared. And in this case, it is 2 squared plus 5 squared equals d squared. And lastly, 4 plus 25 is 29. Therefore, d is equal to the square root of 29. And that is the distance back to the starting point.